Hey guys, this is Kevin, and for my screencast, I'm going to do a problem from the textbook. This is problem number 16 on page 653, and the problem reads, the terminals of a 6-volt battery are connected to points A and B. How much current is in each resistor? How much power is delivered to each? Compare the sum of the individual powers with the power delivered to the equivalent resistance for the circuit. Okay, so for part A, to find the current, we just use the equation, which is current equals potential difference divided by resistor. And from the diagram, we know that the resistance for the resistor 1 is 6 ohms, and that the battery is 6 volts. So we just plug those in, and we get the answer to be 1 amps. For 2 and 3, those are in a series, so we add the resistors up and we get 10 ohms, and then we plug it back into our current equation, and that becomes 0.6 amps. For number 4, we know that the potential difference or voltage will be the same since it's parallel, so it becomes 6 volts over 10 ohms, and that becomes 0.6 amps. For part B, we are supposed to find the power, and the power equation is the current squared times the resistance. And for this, we just plug in the numbers from part A into part B for the current parts. And so you get 1 squared times 6, which becomes 6 watts. And then for 2, 0.6 squared times 4, which equals 1.4 watts. Part 3, 0.6 squared times 6, which equals 2.2 watts. And finally, part 4, where 0.6 squared times 10 equals 3.6 watts. Now for part C, we need to find the sum of the powers and how it compares to the total power. For the sum of the powers, we just simply add all the powers we got from part B, and we get the answer to be 13 watts. Now for the power of the total, we know that the resistance is 2.7 ohms from problem 18.11, and so we just plug that into the power formula, and we get 6.0 squared divided by 2.7 equals 13 watts. And as you can see, the power of the sum equals the power of the total. Hope this helped you guys, because this is about it, and thanks for watching. Bye.